Woohoo! You see those fireworks at the bottom of the screen? That's because we are done with vectors. So today we're going to move on to simplifying, multiplying, dividing, and simplifying complex rational expressions. Boy, that was a mouthful. Okay, a rational expression is a fraction. In the fraction, it has a polynomial in the numerator and a non-zero degreed polynomial in the denominator. Here are some examples of some rational expressions. I have negative 4 over x, that's a rational expression. 2y cubed minus 4 over negative 5y plus 9. This is also, I'm not going to read it all out, but that's a rational expression, and that's a rational expression. Hopefully you get the idea. There's a few things you have to do when you're simplifying. The first thing you need to do is identify any values that make the denominator undefined, right? Because you can't have 0 in your denominator. It's okay in your numerator, but not in your denominator. So you have to look for values that are going to make of x that make your expression undefined. The other thing you want to do is you want to factor your numerator and your denominator completely. And sometimes you need to factor first in order to figure out what will make your denominator undefined. And then the last thing you need to do is you need to divide out any common factors from your numerator and denominator, aka canceling out. So here's my first example. I have x squared plus x minus 2 over x squared plus 2x minus 3. I'm going to look to see if I can tell what would make my function undefined. I can't really tell off the top of my head, so I'm going to factor first, and x squared plus x minus 2 factors into x plus 2 times x minus 1. If you don't believe me, go ahead and FOIL that out and check it for yourself. And then in the denominator, that factors into x plus 3 times x minus 1. Okay, things x can't be. Well, in this factor, x could not be negative 3. So x cannot equal negative 3. And over here, in this factor, x could not equal 1. Otherwise, I have 0 in my denominator. So those are the two places where this function's undefined, or this expression would be undefined. Now, I can look at canceling out my factors. I have x minus 1 that's common to both the numerator and the denominator, and all I'm left with here is x plus 2 over x plus 3. Done. Now here's going to be one for you to try. Go ahead, stop this, and when you're ready, turn it back on and check your answer. Okay, hopefully you were able to see that you needed to factor your numerator and your denominator. If you factor out a negative 1 in the top, you should end up with x squared minus 4x. You could factor out an x from that top, and you would get x minus 4. And in the denominator, you get x minus 4 times x plus 2. This is wrong. That should be a 2. And you would get x minus 4 over x minus 4 here. And you should be left with negative x over x plus 2. It's undefined at either of these points, whether they're canceled out or not. And so that would be x minus 2 and x plus 4. So multiplying rationals, very simple. Just like multiplying fractions, you multiply across the top, well, they are fractions, and you multiply across the denominator. Before I do that, though, and combine everything, I'm going to look to see what I can cancel out. If you look here, I have 5 x's in the top and 3 in the bottom. Well, those are going to cancel out, and I'm left with only 2 up here. If I look at these two terms, y cubed over y to the 7th, I have 3 y's in the top and 7 in the bottom. So that's going to leave me with 4 down there. And then over here, I have 10, and I have 9, and then I have x cubed over x squared. The x squared is going to cancel out, and I'm going to be left with x to the 1st. Y to the 4th is going to leave me 1y in the bottom. From that, I get 3x squared times 10x to the 1st over 2y times 9y. And sometimes we don't think of factoring in the simplest of ways you can factor, but 3x squared, if I break this down into factors, it's 2 times 5 times x, and in the bottom I have 2y times 3 times 3 times y. And if you look, I can cancel out a few more things here. And what I'm left with is simply 5x cubed, right? I have 3 x's total over 3 and then 2 y's, so y squared. And that's my final answer. Here's one for you to try. Go ahead, pause this, and when you're ready, turn it back on and check your answer. All right, let's see how you did. All right, x minus 3 times x plus 5 over 4x plus 20 times x squared minus 9. X minus 3 doesn't factor any further, neither does x plus 5, but I can factor out a 4 from this side, and I get 4 times x plus 5. Over here I have the difference of 2 squares, so that factors into x plus 3 and x minus 3. My x minus 3's cancel out, and my x plus 5's cancel out, and I don't have any factors other than 1. Sometimes people forget that and they put 0. Not true. Big fat lie. Over 4 times x plus 3. And you can leave it like that. You don't need to distribute the 4 into the x plus 3. It's fine to leave it the way it is. In fact, I prefer it. All right. Another thing we can do is divide rationals. I have 5x to the 4th over 8x squared times y squared divided by 15 over 8y to the 5th. Well, if you remember from fractions, when you're dividing two fractions, you reciprocate here and then you multiply. So what I have, oh, by the way, let's define our undefines. I think I've been forgetting to do that. X can't equal 0 and y can't equal 0. So that's where this is undefined. All right, so let's rewrite this as a multiplication problem. Let's see, 8x squared y squared times 8y to the 5th over 15, nothing, just 15. All right, so first off, I see that I have 2 8s, so let's just get those out of here. And I see that I have 2 x's in the bottom and 4 in the top. That's going to leave me with just 2 in the top. I have 2 y's and 5 on the top. That's going to leave me with only 3. And if you look at this 15 here, I'm going to cross that out. That's really 3 times 5. So I can cancel out my 5's too. And what I'm left with is only x squared in the top and y cubed. There isn't anything else, right? No. And in the bottom, I'm just left with a 3. Done. It's as simple as that. Here's one for you to try. Remember, don't panic. First thing you want to do is reciprocate it. You're probably going to need to factor this one before you figure out what x and y cannot equal, or x in this case. Anyway, give this a shot. Turn it back on when you're ready. All right, let's check your answer. Well, first thing, I'm turning this division into multiplication, and reciprocating the other side. And then I'm going to factor both sides, and all four of these terms here need to be factored. And I get x squared. Take out the common factor first. Sometimes people forget how to do that. Times x squared minus 9 times x squared minus 16. And then we took out an x squared over here. And then with this x squared minus 9, that's the difference of two other squares. So that actually turns into x minus 3 and x plus 3. And over here, this is the difference of two squares. That turns into x plus 4 and x minus 4. And factor the bottoms. You can cancel out the x squares, the x minus 3s, the x plus 4s. Well, this is just a mess. And I'm left with x plus 3 times x plus 4 over x minus 1 times x minus 2. And this whole mess up here turns into this less of a mess down here. One more thing to learn, and then I'm going to let you go and practice. All right, complex fractions. What? Look at this. There's a fraction over a fraction. Never fear. If you just remember that that's just another way of writing this. Right? It's the same thing. Okay? So don't panic. The first thing I need to do is identify what x can't be, because once I flip this, then it doesn't matter anymore. It's not this, it won't be the same. So you need to identify it in the beginning. And so if I factor this over here, it's going to be x plus 3 times x minus 3. So x can't be plus or minus 3. And the same thing here. I can't have a 3 in my denominator here, so I don't need to add to this, but 3 can't happen here either. So now that I have done this part, I can flip this and turn it into a multiplication. You know, it's considered very poor taste to have a complex fraction. You're supposed to try to get rid of it. All right, so this turns into 2 over x minus 3. I know you're really concerned about poor taste in math. And this turns into x minus 3 times x plus 3. That's over 5. Your x minus 3's cancel out. And I'm left with 2 and x plus 3 over 5. Done. That is it. That's simplified. And of course, I also have one for you to try. Whoa. Wait a minute. Talk about giving away the store. It looks like I've already solved it for you. We'll try to ignore this. All right, stop. Come back to it in a minute. Okay, hopefully you were able to ignore that, and now I'm ready to reveal the super secret answer. Hopefully the first thing you did was realize that there are no restrictions here. Oops, that is not the pencil. Okay. There are no restrictions here. There's no variable in the denominators, either denominator. So there's nothing that's going to make this undefined because I have an 8 and a 16, both perfectly acceptable. Now, if you rewrite that as first a division problem, I guess, I probably would jump ahead, but maybe you shouldn't. And then you reciprocate and turn it into multiplication. And then you can cancel out. You know, that really looks suspiciously like a laser pointer. No, that's not what I want either. All right, we'll go with it. Cancel out any common factors. It looks like you could cancel out some y's here, some x's, and maybe an 8. Oh, and a 3 too. 3 from the top and a 3 from the bottom. And you'd be left with 2 over 3 xy. All right, I'm going to let you go for now. Hopefully you're really excited about rational expressions, because boy, aren't they exciting. And I'll see you next week or Friday.